So with Unit 7 Worksheet 8, question number 2 or problem number 2, we're going to solve this one just like we did the last one by starting by identifying the number of valence electrons. So I'm going to go and identify the number of valence electrons. I see that I have a carbon, I have a hydrogen, and I have some chlorine. So in this problem, there's one carbon times 4 valence electrons. There's one hydrogen times 1 valence electron. And there are 3 chlorines times 7 valence electrons. So let's see, 21 and 1 is 22, and 4 is 26 valence electrons. And so we need to start by placing our central atom. So in this problem, I have carbon being my central atom. I'm going to attach a hydrogen to that carbon, and I'm going to attach chlorine, chlorine, chlorine. And as I was walking around helping students in class today, one of the things that I noticed was that some people put hydrogen as a central atom, and we don't have hydrogen as a central atom in this case. One of the reasons is that hydrogen should not be the central atom because it only has 2 valence electrons. It only needs 2 valence electrons to have the most stable arrangement of electrons. The other reason is that carbon is the first atom in the formula, and usually the rule says that if there's carbon present, it's usually the central atom. So at this point, I've placed 2, 4, 6, 8 electrons in bonds. So that leaves me with 18 valence electrons to find a home for. So I'm going to put those around my chlorine like so. So I've used 2, 4, 6, 8, 10, 12, 14, 16, 18. And note that I didn't put any on hydrogen because, again, hydrogen already has 2 electrons in the bond. Okay, now the next thing we need to do is identify bond polarity. So I see that I have hydrogen and carbon and chlorine. So I'm going to go and set up my little formula here so I can solve those real quick ones. According to the periodic table, hydrogen has an electronegativity of 2.1 and carbon has an electronegativity of 2.5. And chlorine has an electronegativity of 3.0. When I subtract 2.1 from 2.5, I get 0.4, making it a non-polar bond. If I take 2.5 from 3.0, I get 0.5. Making those bonds polar bonds. So if they're non-polar bonds, we don't have to draw any dipole arrows, but if they are polar bonds, we are going to have to draw some dipole arrows. So I'm going to draw my dipole arrows pointing toward the more electronegative element, like that. If I have to draw dipole arrows, I also have to draw the partial charge. So the partial charge always goes on the side that is closer. The delta negative always goes on the side that is more electronegative, and the delta positive goes on the side that is less electronegative. So that would look something like this on my structure. And then we'd have a delta positive on the carbon. So there's my structure. And then we're going to go and identify the Vesper geometry. So again, carbon is my central atom, and I have one of those. So that's going to be A. There are 4 atoms bonded to the central atom, so that's going to be an X4. And there are no dots or unshared pair of electrons on the central atom, so that's still going to be an E0. So much like problem number 1, this shape, Vesper geometry, is going to be tetrahedral. Now, in this case, though, we are going to talk about the molecular polarity, and the arrows that are pointing, the dipole arrows that are pointing up and pointing down cancel each other out. But the dipole arrow that is pointing to the right toward the chlorine has nothing to balance it out or cancel it out. So that means that this whole structure is going to be a polar molecule. And it's going to be a polar molecule because not all of the arrows are canceled out. And specifically, we're talking about that one arrow that's pointing to the right. So that's the solution for problem number 2 on the polarity worksheet. Again, if you have any questions, please reach out to us or me, and I'll try to help you out with that.